Hey everyone, this is the Wildlife Dwelling Dimensional Probe project sponsored by the GVSU Biology NRM department. Shown in the picture below is our senior project team, which consists of Lam, me, Jamal, Evan, Gage, and Renzo. First, I'll go over some background information for our project. So in this project, we will be focusing on studying the living quarters of the American pine marten. They are members of the weasel family. They're found throughout Canada and the northern United States. They help to control the populations of small mammals and insects. Their populations have also declined in some areas due to habitat loss and trapping for their fur. Next, we'll go over our project scope and key specs. The scope of this project was to design a device that is able to calculate the volume of the living area of an animal, specifically the American pine marten that lives in the tree. The device will give GVSU NRM researchers the ability to gather quantifiable volumetric data from the living quarters of an animal. The key specs for our project is that the volume must be estimated with an error of plus or minus 10%. The device must meet the IP54 standard requirement for dust and water splash protection, and the user interface must be able to communicate wirelessly with a volume measurement device. Next, we'll go over the overall design for our project. In order to get our device into the animal den, we will be using an extension pole. At the top of the pole, we're going to have the adapter, ball joint, extension, and device enclosure. This will allow for high maneuverability, easy access into the wildlife den, and a very small footprint. At the bottom of the pole, we're going to have the tablet and its mount that attaches to the pole. The mount that we chose is a tough and durable mount, allowing the tablet to stay protected and not fall off. And this will be placed near the handle for easy user access. Our device enclosure will house the PCBs, batteries, and time-of-flight sensors. It will be 3D printed using tough 2000 resin. This is a very tough and durable material which will allow it to withstand any drop test. It's a very compact and small design, allowing it to easily fit in any animal den. It is also waterproof, which will be done by using an O-ring between the top and bottom portions of the enclosure and using screws with O-rings. We'll also be using threaded inserts, which will allow for a more durable and stable assembly. Next, we'll go over the electrical design for the project. Shown in the images below is the rigid printed circuit board, also known as a PCB, for our measurement device. This is the brains of our device because it will house the MCU, voltage converters, SD card module, USB-C connector, Bluetooth module, and several other components. This PCB will be connected to another flexible PCB, which all of the sensors will be mounted to. Shown in the images below is the flexible PCB in which the 14 time-of-flight sensors will be mounted to. This PCB will wrap around the inside of the enclosure, which will allow the sensors to spread out over the entire enclosure, capturing the most accurate volume measurement. Next, we will go over our Android application. As you can see in the image below, we have developed an Android application to communicate with the probe. This app is designed to make it easy for users to interact with the device and capture distance readings in real time. The app searches and connects with the dimensional probe using Bluetooth and triggers the time-of-flight sensor readings.